Hey everybody, we are going to check out the Atari Punk circuit, otherwise known as the step tone generator, and it came from a book by Forrest Mims. It was actually one of his engineering notebooks made, I think, back in like I think in the 80s. Originally, I think it was kind of released through Radio Shack, and you can still find them on Amazon, so if you ever want to pick up some good books and electronics, check them out. And I guess we're going to take a quick look and see what it looks like. I went ahead and just laid this out on my breadboard. Didn't put it into an enclosure or anything, but this is just a quick tour of what it sounds like, and then we'll take a look at the circuit in the book real quick, or the schematic, I guess, and compare that to the pin layouts for the datasheet for the this guy right here, and he's internally he's just 2555 timer chips. So let's turn our power on for a sec, and I'm gonna put this up to we'll do like 6 volts or so. Just try that out. And let me grab. I have these little small potentiometers that see if I can actually get the focus there. I've got like these little trim pots here that I can use to turn with my little screwdriver. A little bit more convenient than using the actual panel potentiometers. So this guy controls volume. So if I use him, he'll actually make it quieter or really loud, as you can tell. So you kind of have to choose what volume level won't blow your ears out. And keep in mind, this is only when we're running at 6.3 volts. So if you bump this up to say like 12, that thing gets really loud. So with that being said, let's check this out. Kind of sounds like a motor when it's on this slower one up there. Let's just go ahead and tweak this one now. It's pretty cool. It's like a slow beat drum. Pretty cool. You can hear it stepping tones. And needless to say, if you use instead of using these single turn trim pots, which go the entire spectrum of resistance from basically 0 to the value in a single turn, if you use something that's a little bit more fine grained, then you won't be stepping through so fast on those tones. That's why it kind of jumps around a little bit. So anyways, that's the circuit, and this guy's the book I was mentioning before. It's actually a little collection of some cool stuff that you could do, so highly recommend it. Probably do a review on it sometime. But this would be the actual step tone generator circuit that I was talking about, and as you can see, on the left side we've got pins 2 and 6 tied together, and on the right side we've got pins 12 and 13 tied together. So those are kind of clues to let us know what mode we are actually running in on which chip. So let me actually pull up the data sheet for a sec here. So I said, if we actually look, let me just look back here. I said we had pins 2 and 6 tied together. So we can see 2 and 6 is the threshold and trigger pins. And the threshold and trigger pins, when those are actually tied together, as we learned in the past, that's going to be, oops, not that one. It's going to be this guy. So I'm just on the Wikipedia site, for example, just kind of pulled up the 555 timers, but as you can tell, the pins 2 and 6 are tied together, and this indicates that we are in a astable mode. So that means this guy's always kicking out a signal, he's always oscillating. He doesn't need any kind of trigger because he's pretty much hardwired to the VCC line there through those R1 and R2s. So, and if we look back at our circuit one more time, and we said that pins 12 and 13 are also tied together. Go back to our data sheet one more time here, and you'll see that that's the discharge and threshold pins of the second 555. So if we come over here and we look at the discharge and threshold pins that are tied together in this one, as you can tell, that is the monostable mode. So we have a, in conclusion, we have an astable mode that is triggering a monostable mode. So let me move over to the light a little bit more. So if we look back at that one more time, the output, which is I think pin 5, is going into pin 8, which is the trigger, I think. Let's check one more time here. So yeah, as you can see, pin 5 is the out, and pin 8 is the trigger for the second 555. So really the circuit is nothing more than a astable 555 triggering a second 555 that's running in monostable mode. And you've got the R4 potentiometer here, and that's controlling the volume as we recognized when we did the demo. And otherwise you've got the R3 potentiometer over there and the R1 potentiometer over here. And those guys were helping us with the tone stepping, so it was pretty cool. And that's pretty much all there is to the circuit. A few caps and a resistor in play, but that's pretty much all there is. So if you ever have a chance to play around with this is a really cool short project to put together. Probably took no more than about a half an hour to build it, and I think it's a good experience if you've never played around with the 555s, and sure makes some cool sounds. And if you feel so inclined, throw it in an enclosure, maybe a mint box, whatever you got. And happy building, guys. Take care.